It is said to achieve success, one has to be at the right place at the right time. And here you are with me, Arjun Bhagat, at Toppers Exam Special. Since we are at the right place at the right time, we should do something right. And that's not only study hard, but also to study smart. Today, we'll do just this by studying the topics aldehydes, ketones, carboxylic acids, and amines. Every journey should begin with a destination in mind, so let's take a look at your destination in terms of the marks this chapter holds.
The unit aldehydes, ketones and carboxylic acids carries a total of 6 marks. This means carries 9% of total marks. And the unit amines carries a total of 4 marks out of the total 70 marks chemistry paper. This means the means carries 6% of total marks. These units are very important from the exam point of view. One can expect short answer type questions worth 1, 2, 3 marks or even a 5 marks problem.
Well, now that you know the weightage of this chapter and the type of questions asked in the previous years, let us begin with the preparation for this year's board exams. So let's quickly revise the important points from this chapter and head to our questions.
In these chapters, we did nomenclature of carbonyl compounds, preparation of aldehydes, ketones and carboxylic acids, properties of these carbonyl compounds, preparation and properties of amines, and basicity of amines.
The trend analysis and the revision must have given you a fair idea of the topics to emphasize upon in this chapter. Now let's look at the abilities that you'll be tested on.
Mostly conceptual questions are asked from the chapter aldehydes, ketones and carboxylic acids and amines. However, sometimes representative questions can also be asked on nomenclature or reactions.
Well, to provide you with a better perspective, we have some questions from this chapter. So let's not waste any time and move to the model question of today.
Here you need to tell me A. Why do aldehydes and ketones have high dipole moments? B. Aldehydes and ketones have lower boiling points than corresponding alcohols and acids. Explain. And C. Write a chemical test to distinguish between formaldehyde and acetaldehyde. This one is worth 3 marks and is conceptual in nature. To answer the first part, write the reason that the carbonyl group in aldehydes and ketones contain a double bond between carbon and oxygen. Since oxygen is more electronegative than carbon, the carbonyl group is a polarized group. There is a partial negative charge on oxygen and partial positive charge on carbon. Therefore, aldehydes and ketones have high dipole moments. For the second part, write that the interactions existing in aldehydes and ketones are intermolecular dipole interactions which are weaker than the intermolecular hydrogen bonds present in alcohols and carboxylic acids. And the answer to the last part is that formaldehyde and acetaldehyde can be distinguished by iodoform test. Acetaldehyde will give a yellow precipitate of iodoform with an alkaline solution of iodine, while formaldehyde will not. Remember the class of compounds which give the iodoform test.
Now that you're aware of what all to expect in the examination and also how to answer those questions, you should be all set to start practicing. So let's hit the track with our first practice question.
You have to illustrate these processes. 1. Cannizzaro reaction. 2. Acetylation. 3. Decarboxylation. Also give a chemical equation for each. Not only that, state the chemical test to distinguish between 1. Propanil and propanone and 2. Phenol and benzoic acid. This question is a 5-marker. Since it is a conceptual question, our advice is that you should learn the names of all the reactions well before you enter the examination hall. Let's begin with the Cannizzaro reaction. In this reaction, the aldehydes which do not have an alpha hydrogen atom undergo self-oxidation and reduction in the presence of concentrated alkali to give a corresponding alcohol and salt of carboxylic acid. Moving on with acetylation, in this reaction CH3CO group is introduced by treating the substance with acetic anhydride or acetyl chloride. Electrophilic substitution occurs here. And in decarboxylation, the sodium salt of carboxylic acid is heated with soda lime, that is, a mixture of sodium hydroxide and calcium oxide, to give a hydrocarbon and sodium carbonate. Coming to the differences now. Propanil and propanone can be distinguished by a silver mirror test. Add a few drops of Tollens reagent to both and heat. What do you see? Propanone, being a ketone, does not show any change, whereas the silver mirror is formed on the inner side of the test tube containing propanil. Lastly, phenol and benzoic acid can be distinguished by adding sodium bicarbonate. Phenols give no reaction, whereas in case of benzoic acid, carbon dioxide gas is evolved with effervescence. You just got 5 marks. How does it feel? Every point you write fetches you a mark, so be careful while writing the points. Remember the various reactions of aldehydes, ketones and carboxylic acids.
That was a heavy 5-marker. Let me take you to our next practice question, which will put you to ease. Check it out.
You need to give reasons as to why tertiary amines have lower boiling point than the primary amines of comparable molar mass, and give one chemical test to distinguish between ethylamine and dimethylamine. This is a 2-marker, is based on conceptual ability and rated as average on our difficulty meter. Ready for it? Let's go. Here comes the solution. Primary amines can form intermolecular hydrogen bonds, which is not possible in tertiary amines. Thus, the boiling points of tertiary amines are lower than those of primary amines. 1 mark added to your score. Now for the last part of the question, warm both the amines separately with a few drops of chloroform and alcoholic KOH. You will notice that ethylamine gives an offensive smell of carbylamines. On the other hand, dimethylamine, being a secondary amine, does not give this test. 2 marks secured. You are a sure shot acer now.
Reactions are an integral part of life, be it emotional reactions or chemical. That is why they make an integral part of this chapter. So while writing the reactions, be very focused and aware of what you're writing. Writing the wrong reactions would make your entire answer go wrong. Well, with this advice, let's try another practice question.
Here we have few situations. You have to account for them. 1. Why does electrophilic substitution in case of aromatic amines take place more readily than in benzene? 2. Can tertiary amines undergo acetylation reactions? Explain. Take a look at the explanation for each. Remember, this is a 3-marker. 1. Amino group in aromatic amines strongly activates the benzene ring. This is due to the delocalization of the lone pair of electrons on nitrogen atom over the aromatic ring. However, no such delocalization occurs in case of benzene. Hence, electrophilic substitution in case of aromatic amines takes place more readily than in benzene. 2. And to answer the second part, you should know that no tertiary amines can undergo acetylation reactions. This is because they do not have a replaceable hydrogen atom. So you have 3 marks more in your kitty.
We are halfway down, loads more coming up, more practice questions and HOTS questions and special tips to help you give your best shot at the exams. And also remember to log on to our website www.topperlearning.com and get all you want in relation to your exams. Since we are going away for a short while, you scratch your brains to solve this breaking question. See you after this short break.
Why aqueous ethylamine turns red litmus blue? I'm sure you'll be back to crack it. Check the answer after the break. Before we went into a break, I asked you a question. Why aqueous ethylamine turns red litmus blue? The answer is, aqueous ethylamine is basic in nature because of the presence of free OH- ions. Hence, it turns red litmus blue.
Welcome back, I'm Arjun and you're watching the exam special on the topic aldehydes, ketones, carboxylic acid and amines. In this episode, we glanced through a model question and some practice questions related to the reactions of aldehydes, ketones, carboxylic acids and tests to distinguish between these. We also discussed a question on amines and their reactions. But there's more to come, so here goes the next practice question.
This question asks you to account for some observations. So here is another explanation-based question. Let's see what the observations are. 1. The pKb value for aniline is more than that for methylamine. 2. Methylamine in water reacts with ferric chloride to give a precipitate of ferric hydroxide. And 3. Aniline does not undergo Friedel-Crafts reaction. Let's reason why we come across these observations. This is a 3 marks conceptual question and was asked in CBSE 2008. As the question is divided into 3 parts, each part carries 1 mark. So do it accordingly. In methylamine, the plus I effect of CH3 group increases the electron density around the nitrogen atom, thereby increasing its basicity. In aniline, the resonance effect causes delocalization of the lone pair over the ring. Therefore, the lone pair is less available for protonation, thereby decreasing the basicity of aniline. Since aniline is less basic than methylamine, therefore the pKb value of aniline is more than that of methylamine. For the second part now, methylamine in water gives OH ions which reacts with ferric chloride to give a precipitate of ferric hydroxide. And lastly, aniline does not undergo Friedel-Crafts reaction because of the formation of salt with aluminium chloride, which is used as a catalyst in the reaction. Due to this, nitrogen of aniline acquires positive charge and hence acts as a strong deactivating group. This prevents aniline to undergo Friedel-Crafts reaction. Remember that aliphatic amines are stronger bases than aromatic amines.
By now you should be enjoying the practice questions. This chapter isn't that difficult if you know the reactions well and the concepts are clear in your mind. We are headed for the last practice question now. It's the finale question, so pay close attention. Now that we have already passed the ocean, the sea won't be a big deal. So check out how rough the sea is.
You have to explain that out of methylamine or methanol, which has a lower boiling point. Also, you are asked to give reason. This question is of average difficulty. You can get 2 full marks if you know that methylamine has a lower boiling point than methanol, because methylamine is polar and can form intermolecular hydrogen bonds. However, its tendency to form intermolecular hydrogen bonds is less than that of methanol, which has a highly electronegative oxygen atom.
With this, we come to the end of our practice session. It's time to go to our HOTS segment now. HOTS questions have been introduced by the CBSE to test the high-order thinking skills of the students. This also encourages students to think out of the bag. So take a look at what we have in store for you.
In today's HOTS question, you are given that an organic compound A with molecular formula C8H8O forms an orange precipitate with 2,4-DNP reagent and gives a yellow precipitate on heating with iodine in the presence of sodium hydroxide. It neither reduces toluene's nor the Felling's reagent, nor does it decolorize bromine water or the Bayer's reagent. And what's more, on drastic oxidation with chromic acid, it gives a carboxylic acid B, having the molecular formula C7H6O2. You need to identify the compounds A and B and explain the reactions involved. This is a 3 marks conceptual question and is of average difficulty. We have done a couple of such questions, so I'm sure you will get this one right, but I would still say that make sure you draw the position of the double bonds and functional groups correctly. Take a look at the answer. A forms 2,4-DNP derivatives, so it should be an aldehyde or a ketone. Since it does not reduce the toluene's or Felling's reagent, A must be a ketone. A responds to the iodoform test, so it has to be a methyl ketone. Now the molecular formula of A indicates a high degree of unsaturation, yet it does not decolorize bromine water or Bayer's reagent. This indicates the presence of unsaturation due to the aromatic ring. Coming to compound B now, compound B being an oxidation product of a ketone should be a carboxylic acid. The molecular formula of B indicates that it should be benzoic acid, and compound A should therefore be monosubstituted aromatic methyl ketone. From here we can deduce that A should be phenyl methyl ketone or acetophenone.
Now I'm sure that you'll crack your exam completely. Our website also has more questions, so log on to www.topperlearning.com and practice those as well. Okay, now if you remember, there's always a things to remember section at the end of every chapter in our textbooks. Similarly, we also have some exam tips that you should keep in mind while preparing for the exams, so take a look.
Remember that aldehydes and ketones undergo nucleophilic addition reactions, in contrast to the electrophilic addition reactions observed in alkenes. Learn all the named reactions along with their mechanism. Remember that fatty acids are the higher members of aliphatic carboxylic acids, not aromatic acids. Remember that amines are derivatives of ammonia and act as Lewis bases. Alkyl amines are a stronger base than ammonia, while aniline is a weaker base than ammonia.
These tips should be kept in mind while revising the chapter and also while answering the questions. Well, it's time for me to say goodbye. We'll be back with another exam special on a new topic. Till then, best of luck and keep studying smart. Take care and goodbye.